So this is thyristor control of three-phase synchronous motor, that is speed control of three-phase induction motor. So this is a synchronous motor and it's a stator part, and stator part is connected with three-phase AC supply, 50 hertz, 440 volt. And it has a rotor winding, that is a field winding, and this field winding is excited through the DC supply. And by controlling the excitation, we can control the power factor of the synchronous motor, and by controlling the frequency as well as the voltage in the stator winding of synchronous motor, we can control the synchronous speed of the motor. Then how to change this frequency voltage? So here the input of this stator winding is connected through three-phase AC supply. This AC supply is connected with the three-phase control rectifier. So by controlling the firing angle from zero to its highest value, we can control the input DC voltage to this inverter. Using this LC filter circuit, we will minimize the harmonic so that we will get the steep DC voltage. And this variable DC voltage that we will get from this three-phase rectifier across the inverter input, we will get the variable AC voltage across the output of the inverter. And by providing the proper switching pulses to the thyristors, we will get variable frequency. So by controlling the on and off time of this devices used in this inverter, we'll get the variable frequency. So using phase control rectifier, we will get the variable AC voltage, and using this inverter, we'll get the variable frequency. So here frequency will be we can change by the inverter within itself. And this output of this DC voltage from this phase control rectifier that we will apply to the field winding, and so that we will get the field MMF. And using this frequency and variable voltage, we'll get the variable speed of the three-phase induction motor. So this is about the thyristor control. And another way is using the line commutated inverter, same case, but it is line commutated inverter. So this is phase control rectifier, and by providing the gate pulses to these thyristors during the inverter mode condition, we will get the variable frequency as well as the variable voltage. Same for circuit diagram, but it is using line commutated inverter. Okay, and here we will get the variable induced EMF in the stator winding by controlling the firing angle to this thyristors. And by firing this thyristors, we will get the variable frequency so that we can achieve the variable AC voltage and variable frequency across the input of stator winding. And here the field winding is connected with the DC supply. Either we can connect this DC supply from separate phase control rectifier winding to get the variable voltage for power factor control, or we can supply this three-phase DC supply from the output of this phase control rectifier. That is, from this two terminals we can connect across this DC supply so that we will get the variable DC voltage for the field winding. So this is all about the AC drive in synchronous motor using power electronics circuit. Thank you very much.